Hello, ladies and gentlemen. I hope you and your family are all well and safe during the difficult times. I'm Chu Lianglin, Director General of the National Space Organization in Taiwan. I'm happy today to introduce National Space Organization and talk about Taiwan Space Program in the presentation. Before my speech, let me briefly introduce NSPO. NSPO is one of the government-supported research institute affiliated to National Applied Research Lab. We located in the Hsinchu Science Park, which is a 1-hour drive away from Taipei City. We have two buildings located in Hsinchu Science Park. The first one is a headquarters with a satellite operation and the control centers. Nearby to the headquarters is a satellite integration and testing buildings. The role of NSPO is serve as the National Space Agency. Our region is become a center of innovation and the essence for space technology development. We conduct space program for Taiwan government with a Taiwan industry capability. For the human resource, right now we have over 220 staffs. Over 80% are engineers and researchers. Our annual budget is more or less $80 million. NSPO has been establishing satellite facility in the past 2 decades. This includes EMC, EMI, and coil chamber, thermal vacuum chambers, 3-dimensional precision coordinate measuring machine, vibration test bench, and acoustic chamber, mass property measurement fixtures, and so on. We have also established a mission operation and the control system. This includes satellite operation and control system. We have 4 telemetries, tracking, and the control station in Taiwan, and the cross-platform satellite operation control system, mission planning, and the scheduling system. We have also established image processing center, and we have also have the GNS radio occultation data processing system. So here is a slide of the surface long-term space program. In our surface space program, including 4 major missions. The first one is a high-resolution Earth observation remote sensing satellite constellation. It consists of 6 small satellites. The first satellite is going to be launched in 2022, but probably postponed to 2023 because of the COVID-19. The satellite can provide the image resolution up to 1 meter for panchromatic image and 2 meters for multispectral image. The next one is ultra high resolution Earth observation satellite constellation. There are 2 satellites to be built. The first one is going to be launched in 2026. The next one is a SAR satellite constellation. There will be 2 satellites. The first one will be launched in 2027. We also have the scientific innovation mission. This includes deep space exploration. This slide shows you the Triton. This is the next satellite to be launched. This is a Wind Hunter satellite, a kind of meteorological satellite. The satellite is a 300 kilogram class satellite with indigenous developed key components or developed by NSPO and the local manufacturers. The showing here is a sum of the key components such as a GNS reflector matrix, H2O2 propulsion system, fiber optic gyros, power control unit, onboard computer, and the GPS receivers. The satellite is going to be used to predict typhoon density and the path among other numerical weather prediction applications. This satellite is scheduled to be launched in 2022. Next to the Triton is a Formosa 8. This program is serving as a follow-on mission to Formosa 5. Formosa 5 was launched in 2017. This satellite can provide the image with 2 meter resolution for poor panchromatic image and 2 meter resolution for multispectral image. And the Formosa 8 program plans to develop 6 remote sensing satellites for global coverage and provide multiple local rebates over Taiwan. The first satellite is going to be launched in 2023, and the second one in 2024. And the satellite is going to provide a genetic bus platform for all satellite missions in surface National Space Program. Over 85% of the components were developed and made in Taiwan. This satellite also provides risk control such as redundancy with new design and heritage design components with an affordable cost. That is a commercialized approach. Show you here is a 15 key component of the engineering qualified modules developed in the past several years. This includes optical payloads such as mirror filter, corrector lens, and so on. And for the electrical parts, onboard computers, power control units, S-band transmitter, and so on. And for flight control system, GPS receiver and mass RU. And for the mechanical system, H2O2 propulsion, radiation control system, thruster, valves, and filter, and so on. Next to the Formosa 8 is Formosa 9 programs. This is ultra-high resolution satellite constellation. The unique feature is this satellite will be equipped with TDI CMOS chips. The chips is indigenously developed by NSPO, collaborate with the Taiwan semiconductor manufacturing companies. This satellite also equipped with the intelligent image function, such as artificial intelligence seekers used to recognize ships over the ocean, and also used for cloud avoidance for the major cameras. This satellite is going to be launched in 2026 for the first satellite. Next to the Formosa 9 is the Formosa 10. This is a synthetic aperture radar satellite constellation. Now it's in the phase of the research and development of the key technology. Showing here is the passive antenna. There are 2 configurations and the active phase array antennas. The satellite design and the branch manufacture will be started in 2024, and the first launch is scheduled to be 2027. Next to be introduced is a 5G LEO communication program. This satellite program is trying to build up a low Earth orbit communication satellite to be designed and manufactured by NSPO, collaborating with the domestic manufacturers in Taiwan. The first launch is scheduled to be in 2025, and the additional 6 satellites constitution will be fulfilled by 2030 to achieve 1 hour revisit goals. The purpose of this program is to promote the growth of the satellite communication industry, especially in Taiwan. And the NSPO trying to help local industry become the key players in the international supply chain. For application, there are 2 paths for the remote sensing application. NSPO has launched Formosa 2 and Formosa 5 in the past several years, We have already accumulated fast satellite image for a variety of the application. And another type of application is weather predictions. We have also launched Formosa 3 and Formosa 7. Both are meteorological satellite constellation. We have collect high density of satellite radio occultation data. Actually, the collected radio occultation data has released to the international users in the March this year. You can see in the right lower corner of the website, this is a web page for the international user to log into the web page to access the regular occultation data for application. It's free of charge to international users. We also build up the open data cubes to accumulate the Formosa 2 and 5 for the variety of the image application. Finally, let me make a summary of my talk. NSPO is committed to pursue a center of excellence and innovation for space technology in Taiwan. We try to conduct a space program with our government strengths and to improve the global competitiveness. We try to become one of the significant contributors to the global space community by providing pronounced social impacts and to promote frontier space science research and to enhance international collaboration. We do have lots of the opportunity to cooperate with our international partner in the next 10 years. All opportunities are open to our partner. If you are interested in to cooperate with the NSPO, please feel free to contact with us. This is my talk. Thank you for listening.